Hi, Vicky.
Hi, Shane.
So I wanted to ask you, have you ever seen a shooting star or even had got like the opportunity to gaze up at a very dark and star-filled night sky? And asking you this as folks, we both live in like cities-ish now and have a lot of light
Yeah.
pollution.
Yeah. So I'm sure I saw stars before this. I grew up in northern New Jersey, which I'm sure I've mentioned. I mention it a
Hmm.
lot. But so lots of light pollution. And I camped and everything when I was a kid. So I know I saw stars. But the first time it really, really clicked, I went to a science summer camp when I was in high school in
Ah,
the Adirondacks.
okay.
Shout out to ESSYI. But yeah, we went camping for a few days in the Adirondacks to do some, like, sampling of water and things like that,
Mhm.
and, it was just so dark and the stars were so bright. I feel like that's
Okay.
my first real, like, "Whoa" moment.
Yeah, I grew up in very rural Pennsylvania, so I actually got to see a decent amount of night sky, but
Mhm.
one recently, and you and I will catch up on this, but my
Oh,
partner and I
right.
went to the Galapagos,
Yeah.
and we were on a boat for like a week and a half, and it was amazing. But one thing I was really looking forward to is just how dark it is there. I mean, you can just the night sky is amazing, and I like it was cloudy the first night, the second night go up, and just this beautiful, beautiful sky and
Mm.
more stars than I've ever seen in my entire life. While the boat was going through very choppy seas.
Oh.
And let's just say that I enjoyed the night sky, but being on deck was more of a necessity than anything because the moment get down to our cab, I it took me a while to adjust to being on a boat.
Oh,
We
no.
we won't get into more than that, but the sky, absolutely lovely.
That's you just wrote a really good Yelp review. Yeah.
I'll make sure I include it.
Yeah.
Science is fascinating, but don't just take my word for it. Join us as we hear stories from scientists for everyone. I'm Shane Hanlon,
And I'm Vicky Thompson.
and this is Third Pod from the Sun. So we got a little off topic in our introduction, as we
Sure.
do.
Yeah. Yeah.
But to bring us back on course, little bit of reeling us in, I'm going to bring in producer Katrina Jackson. Hi, Katrina.
Hi, Shane.
Okay, what are we doing? What do you got for us?
Yeah, so I thought we'd start off with just a short pop quiz, if that's okay.
Ooh, it's not often that I get quizzed. I'm always asking Vicky questions.
Yeah,
Glad to have you on the carpet.
All right, go for it.
great. So can either of you tell me what is an asteroid?
Um,
It's a
Besides
rock.
it's a rock that is usually a world-ending event.
It's rock moving
Rock.
through space. Rock.
Yeah. Big rock.
Big rock.
Yeah.
Okay. And what is a comet?
Big icy rock?
Oh, yeah. I'm with Shane on that.
Okay. Yeah, big rock, big icy rock. That's pretty much about right. But yeah.
I love being right. It brings me joy.
Right. So, and with a lot of things in nature, sometimes it's a little hard to tell the difference. And it turns out there's probably some degree of overlap between asteroids and comets. And there's even a thing called extinct comets, where after a comet spends a lot of time near the sun and it loses some of that ice, it might look more like an asteroid. And so, to help explain all of this, I talked with an expert on small solar system bodies from the OSIRIS-REx mission.
OSIRIS-REx. Is that an acronym?
It is, yeah. So it's a long acronym. I'll see if I can remember it. So OSIRIS-REx is origin, spectral interpretation, resource identification, security, regolith explorer.
Should
Yeah.
Yeah,
Thank you.
we'll clap for that. Very good. Very
I'm always a
impressive.
little proud when I can remember that whole thing. So OSIRIS-REx is a NASA mission that recently went to capture a sample from an asteroid named Bennu, and it's currently on its way back to Earth to return that sample. And so for this episode, I got to chat with the deputy principal investigator of that mission.
My name is Dani DellaGiustina, and I am the Deputy Principal Investigator of NASA's OSIRIS-REx mission. I'm also an Assistant Professor of Planetary Science at the University of Arizona.
What I'm hoping to learn about today is all about asteroids and comets. Can you explain what exactly is the difference between asteroids and comets?
Yeah, that is a really good question. So the difference between asteroids and comets in general is that asteroids tend to be small bodies, debris in the solar system left over from the formation of the planets that is composed primarily of rock. And comets are pretty similar. They're also debris left over from the formation of the solar system, but they tend to be more icy. So they might have dust and rocks in them too, but predominantly they're composed of ices and other volatiles. And when I say the word volatiles, I just mean a material that heats up and vaporizes really quickly compared to rocks, for example.
Is it easy to identify what is an asteroid and what is a comet, or is there kind of a bit of overlap?
Yeah, so that is a really good question. There are things that we think of as being a little like asteroids and a little like comets at the same time. These are called transitionary objects. So they have characteristics of each. And when we think about the types of small bodies that exist in the solar system, they probably exist more on a continuum between these two different classifications than in distinct boxes. So in some cases, it's easy to tell the difference, but there's some objects that leave a little bit of ambiguity.
Can a comet become an asteroid? I'm hearing about, quote, extinct comets. What is that?
That's a really good question. So you could think of some extinct comets as comets that became asteroids, but what an extinct comet really is it's a comet that's expelled most of its icy material, those volatiles that I mentioned earlier. And that's because comets that make their way into the inner solar system, every time they get close to the sun, that material will vaporize away. And so there are some objects that are, like I mentioned, transitionary, kind of in the middle, but there are some differences as well. So we know that comets and asteroids formed in different parts of the solar system really early in its history, and that it makes sense because comets had to have formed far enough away from the sun that they could preserve those ices and volatiles. And they typically will have more what we would say eccentric orbits than most asteroids. So their orbits have a slightly different shape versus asteroids. But there are some extinct comets that are out there, or some objects that we thought were asteroids. And then later, after observing them further, we saw that they have some cometary-like activity, which just means that they might show a tail or a coma from time to time.
Okay, so it sounds like we were kind of right. So asteroids and comets, both small rocky bodies that formed in our early solar system. But in general, asteroids formed in the inner part, right, closer to the sun, and don't necessarily have much ice in them, whatever that ice might be made up of. And comets are from the outer solar system, so they may have ice. I get that that's very simplistic, but I think that's right.
That sounds right, but there's still some overlap, so there could be some that are sort of in between an asteroid and a comet.
Yeah. So there's some overlap. There might be some asteroids that have some more comet-like traits, or comets that have some more asteroid-like traits. And as we were discussing, there are extinct comets where the ices and volatiles in the comet have vaporized away.
Okay, so how does this tie into the OSIRIS-REx mission?
Yeah, so I didn't realize that OSIRIS-REx had any direct connection to extinct comets until recently, but conveniently enough, as I was researching this story before the interview, I saw a paper from earlier this year that was proposing that maybe the asteroid OSIRIS-REx visited is actually an extinct comet. And so the paper was actually talking about Yeah, the paper is actually talking about a different asteroid called Ryugu, which is the asteroid that Japan visited with their Hayabusa 2 mission around the same time that NASA was visiting asteroid Bennu. But the asteroids Ryugu and Bennu are really similar, both in appearance and composition, so the paper was suggesting that they might have formed in the same way.
Does that mean that Bennu might have actually been an extinct comet?
Maybe. So I did ask Dani about this hypothesis, and she seemed kind of skeptical.
I have seen that paper, and I have some thoughts about it. So the idea, at least the idea that was proposed as part of the Ryugu paper. So Ryugu is the dark top-shaped asteroid that looks a lot like Bennu, that was visited by the Hayabusa 2 mission. And this recent paper that came out suggesting that Ryugu is an extinct comet hypothesizes that the parent body of Ryugu was a comet, and over time, as it made close excursions with the sun or migrated a little closer towards the sun, its icy and volatile material eventually evaporated. And what is left is sort of the interstitial, or the in-between rocks and dust, and that it's almost like a lag. You can think of that as modern-day Ryugu. And so as part of that paper, they did draw the comparison, just like you did, Katrina, that Bennu and Ryugu are really similar. Maybe this could be a possible theory for Bennu's formation. But the one thing that I noticed that paper did not account for is the fact that we have seen on Ryugu's surface what we call exogenic material. And so that's just material that originated from a different asteroid on its surface. And on Bennu, we saw really clear evidence of this as well. We actually saw material from asteroid Vesta on asteroid Bennu, which is kind of wild. And at least in Bennu's case, the only way that or the most probable way that that could have happened is on Bennu's parent body. So Bennu is a rubble pile asteroid. We expected that it had a parent body, a bigger asteroid that was catastrophically disrupted and scrambled up by a big impact. And then Bennu formed from the fragments of that giant impact. And on Bennu, we see, like I said, this exogenic material, so this material that came from a different asteroid. And we also see other signatures of impacts on it, like these things called breccias, which are when you have one type of rock mashed up with another type of rock. We see this with Bennu and that Vesta-like material. And all of this points to collisions between rocky bodies closely after, either before or during the formation of Bennu, and maybe during the formation of Ryugu, based on what they've seen based on the Hayabusa 2 data. So I think from that perspective, it makes the hypothesis that these bodies originated from comets that sort of, vaporized away and left over little debris piles a bit more challenging. And I would have liked to have seen some accounting of that evidence in this most recent paper on Ryugu.
Okay, so sounds like you're leaning more towards thinking that Bennu is an asteroid and not an extinct comet.
Yeah, I think that Bennu and its parent body, there is a lot of evidence that there was water on Bennu's parent asteroid. We see a lot of hydrated minerals on Bennu. And this isn't free-flowing water, but it's water that's kind of bound up within clay-like minerals. And so I think these objects are probably somewhere in between the asteroid and comet ends of this spectrum of different objects. But I think I'm coming down pretty firmly on the side of asteroid.
So maybe Bennu might be more of just like a soggy asteroid versus a comet.
Yeah, that's what Dani tells me. And full disclosure, I had actually met Dani way back in 2008 My research advisor while I was in undergrad at the University of Arizona was Dante Loretta, and he's now the principal investigator for the OSIRIS-REx mission. And Dani was in that same research group. We overlapped by a semester or two. Then eventually I went on to do science media, working with NASA and as a freelancer. And Dani continued in research, but she didn't really take the traditional academic path.
Yeah, so I've had kind of a non-traditional career path in some ways, but in other ways, I've also been doing this for a really long time. So I got involved in the OSIRIS-REx mission before it was OSIRIS-REx, when it was just called OSIRIS, and it was proposed as part of NASA's Discovery program. I was involved as a student. I was the undergraduate principal investigator for a student collaboration experiment that was intending to measure the cosmic radiation flux around an asteroid and how it might decrease in the shadow of that asteroid. Even though that instrument never came to be, I got a lot of really good experience just working on a big NASA mission proposal, understanding what is required to build a spaceflight instrument, and sort of learning the ropes of that whole process. A couple of years later, when OSIRIS-REx was funded and being built and for its journey to Bennu, I got involved on the image processing team. I was eventually promoted to the lead image processing scientist and then became the deputy principal investigator after our former deputy PI retired last year. So in some ways, I've been working on this program for a long time, but in other ways, I went to grad school and I got a master's degree shortly after my undergrad. But then I just worked for a number of years on this mission and developing other spaceflight programs. And it wasn't until just a few years ago that I went back and did a PhD and started entering a more traditional career stream in academia. But it's all been driven by a really strong interest in our solar system and how it formed, and sort of what are the clues that we can gain by studying small bodies about that process of solar system formation.
So how much more responsibility is the deputy PI role than what you were doing previously?
I would say that the deputy principal investigator role at this point in time is not, it doesn't add more responsibilities necessarily, but they are different responsibilities.
I assume you probably at least have a bigger office now than you did in undergrad. I don't know if you remember,
Yeah.
but I actually took your old office in undergrad.
Oh, did you? That little closet. Yeah, I have, our team just moved from the Drake building, which is where we did all of the mission operations for OSIRIS-REx, or science operations for OSIRIS-REx, back over to campus. So I'm in the Kuiper building again. I do have a window this time. So a couple of challenges that I've had, would say that I was sort of operating as a research scientist. I was working as a research scientist before I had a PhD. And while the vast majority of people were always fine with that fact, I would say that there was a small minority of people that I did think there was a bit of a bias because I didn't have a PhD, even though I'm, operating grants and working in a research scientist capacity on a NASA mission. And then when I was getting my PhD while working full time, was extraordinarily challenging. And I'm not always sure if that was the best route to go. I can't recommend it, but it's the route I took and it worked out for me. So I think that those have been, kind of taking this non-traditional path, not going right from my master's into a PhD, and deciding to work and gain some experience beforehand. It's definitely made things nonlinear for me, and there's just been some challenges associated with that. And then I became a co-investigator on a NASA mission when I was relatively young, as far as these things go. So I was my late 20s. And again, I think there's just some biases that crop up when you're a very junior person on the team, but you're in sort of a leadership and management role. That can cause some friction sometime. But I think in the end, everything worked out. And so I think if you know what you love to do and you're happy to get up every day and do it, that certainly can create a buffer against challenges.
All right, so that does sound pretty challenging, being a young person in a leadership position on a NASA team and not having your PhD yet.
It does, yeah. And that's not the only challenge Dani talked to me about. She also told me about trying to avoid polar bears.
Wait, what? Wait, polar bears? What are we talking about?
Yeah.
This just took a turn.
Yeah, she works in Arizona.
Yeah, she does. Yep. But yeah, so Dani, while she was working with OSIRIS-REx, she was also, for the past few years, working on her PhD. And her PhD work was on a different topic altogether. Yeah, she was helping develop seismometers for spacecraft missions to icy worlds like Europa, which is a moon of Jupiter. And shortly before the first images of asteroid Bennu came back from OSIRIS-REx, Dani was out doing fieldwork in Greenland.
Right before the spacecraft got to Bennu and we could kind of see it as a little world, not just a dot of light, I was doing a pretty extensive field campaign in Greenland. And there is a fairly substantial polar bear risk when you're doing field work in Greenland. We have to sleep with tripwire around our tents and an electric fence around that. We all have to be trained to shoot a shotgun. And so I remember just being so concerned that something was going to happen in the field and I wasn't going to see Bennu. And I had been waiting for so many years for this moment when our cameras were going to resolve the asteroid and I was going to be able to see it as a world and not just a point source of light. And when you're in the field, you're doing a lot of pretty manually intensive work. We're riding in helicopters on a regular basis. And so it's just, there's a fair amount of occupational hazards. And I just remember being so like, I have to just get through this field season intact so I can get back home. I know those images are going to be coming down in 2 months and I need to see Bennu before I die.
Oh no. Did you ever see a polar bear while you were there?
No, luckily I have not ever encountered a polar bear and I would really like to keep it that way.
Okay. Wow. Yeah, that would have been a bummer to be taken out by a polar bear before getting to see the images.
Yeah, it's just really bizarre when you spend years of your career getting ready to take images of something that you've never seen before. It really is an odd experience to have. And then you see it and you're like overwhelmed. It's so cool.
Yeah. So when those images came back and you were safe and home from the polar bears, what was the most surprising thing that you ended up seeing with Bennu?
Yeah, so really early on, some of the first images of Bennu that were returned looked so similar to asteroid Ryugu, which is the asteroid we were talking about earlier that was visited by the Hayabusa 2 mission. And so at first we were like, oh, did we go to the wrong place?
That would be an interesting mistake.
Yeah, but as we started getting a little closer to Bennu, we were all really, really surprised by the amount of rocks on its surface. But seeing those on Ryugu a couple months beforehand had prepared us for that possibility. So I think the thing that was truly surprising were these very, very bright rocks that were, 10 times brighter than the background surface on Bennu that showed up in a couple of small, places here and there peppered throughout the asteroid. And those were the rocks from Vesta that I mentioned earlier. But we weren't expecting to see those. And they were just so much brighter than Bennu that they really kind of looked like beacons on its surface when we were returning those initial images. They were pretty surprising. So that was pretty memorable and one of the things that personally surprised me the most because we hadn't been prepared for that possibility. Seeing Ryugu a couple months before Bennu had sort of begun to mentally prepare us for a rockier than expected surface. And I think just the overall feeling of seeing images come down where you're getting closer and closer to the asteroid, you're seeing, details that you couldn't see in earlier images. You might see a little rock and it looks funny and, the image just came down. Probably the first person in the team to see that image. And then you realize, well, I'm probably the first person in all of human history to see this little rock. It's a pretty cool feeling getting to look at images of these distant worlds every day.
I can't imagine being on the imaging team of one of these missions and getting to be the first person ever to see rocks on a different world. It does sound pretty cool.
Yeah, definitely. And I know we mentioned Vespa. No, not Vespa. It's not a scooter. Vesta. Yeah. So we mentioned Vesta a couple times. Katrina, what is Vesta?
Yes, so Vesta, not the scooter, is the name of a large asteroid in the main asteroid belt between Mars and Jupiter. And Vesta, it has a really distinct composition. And a while back, Vesta was to have been walloped by a smaller asteroid because we find chunks of Vesta in all sorts of places. There are a lot of meteorites on Earth that we believe came from Vesta. And as Dani was telling me, apparently, there are even chunks of Vesta on asteroid Bennu. And that's one of the reasons why she doesn't think Bennu is an extinct comet, because in order to have crossed paths with the debris from Vesta way back when, Bennu had to have been in the asteroid belt with the other asteroids and not in the outer solar system with the comets.
Okay, so asteroids smashing into each other and chunks flying through the solar system makes me think about the obvious. What if one of these asteroids hit Earth? Or a comet, or an extinct one.
Well, okay, so wait, just to be clear, I have to pop in here because
Please.
I wasn't thinking of Earth's extinction when developing this series. That wasn't on my mind. It wasn't. But okay, we're here now, and I'm curious. So what about it?
Yeah, so Dani and I, we did get into that briefly. I asked her about whether the distinction between comets, asteroids, and extinct comets makes any sort of difference in terms of planetary defense, like for planning a mission to deflect one of these objects to prevent it from hitting us.
Well, there's a lot to unpack there. So I'll just say that for a lot of the asteroids that we visited recently with spacecraft, they appear to be rubble piles, which means they're very loosely gravitationally bound piles of rocky material. And for a comet, we might expect that to be a bit more consolidated because it would have that icy material that's sort of binding everything together. We would want to understand the material properties to design the appropriate mitigation technique. And there's a number of different mitigation techniques that have been theorized, but my preliminary thoughts are it would kind of come down to how cohesively bound is the small body in the cometary case versus the asteroid rubble pile case.
I just had such a great time listening to this interview because Dani, frankly, is just so freaking impressive.
Yeah, she is. And actually, since recording this interview, they announced that they're going to be extending the OSIRIS-REx mission, and the new phase is going to be OSIRIS-APEX, that's visiting a different asteroid. And for that extended mission, Dani's actually going to be the principal investigator, which is really impressive. I think she's going to be one of the youngest NASA principal investigators for a mission.
Very cool.
That's super cool. And she has an asteroid named after her, right?
She does. I believe the number is 133744 DellaGiustina. And actually, fun fact, I have an asteroid named after myself as well.
You do? What's its name? What's its number?
I made sure to look it up before the interview. my asteroid is 120353 Katrina Jackson.
And how does one get an asteroid named after themselves?
So basically, pretty much everyone involved with the OSIRIS-REx mission ended up getting an asteroid named after themselves. And I had worked as a video producer on some of the videos for OSIRIS-REx, and so that was kind of a cool reward that you don't get with most other missions, getting something named after yourself.
That's really neat.
Yeah. And I'm just going to apologize in advance that we at Third Pod can't name an asteroid after you for your contributions with us.
Oh, man.
But we very much appreciate it.
Okay.
Yeah. If we could, we would.
If we could, we would. All right, folks. Well, that's all from Third Pod from the Sun.
Thanks so much to Katrina for bringing us this story and to Dani for sharing her work with us.
This episode was produced by Katrina with audio engineering from Collin Warren.
We'd love to hear your thoughts on the podcast. Please rate and review us. And you can find new episodes on your favorite podcasting app or at thirdpodfromthesun.com.
Thanks all, and we'll see you next week. I'm going to hit record. You don't have to tell me about funny accents. My Western Pennsylvania made for This American Life podcasting voice.
Do you say measure?
See, it's hard. You can't no, I say measure, but I say, Kristen does really well. I say R and R, and I say pull and pull. I don't differentiate words with vowels. What are those? Homonyms?
Vowels?
No. What are the ones that sound the same, just spelled different? Homonyms, I'm really bad about. They are the same word for me. I'm bad with vowels. That's a great thing to be as a professional science communicator with their own podcast.